This is the screencast for section 4.1, example 5, angular and linear motion. Now the difference between angular and linear motion is linear motion is more of what you're used to. A car travels at 20 miles an hour, a person runs at 8 miles an hour, whatever the case may be. A linear, you're traveling over a line. Angular motion is talking about how fast something is spinning. So like your car has rotations per minute or revolutions per minute. A fan speed has rotations per minute, etc. So angular speed, by your book's definition, is measured in units like revolutions per minute, and linear speed is measured in units like miles per hour. So you travel along a line versus spinning around an axis. So we're going to do some unit conversions or stoichiometry, kind of like we did back in chapter 1. The biggest conversion we have to remember in this section is that 1 revolution equals 1 circumference. So think about a tire. When a tire rotates once on its axis, the entire circumference of the tire will go along the ground, pushing that car a distance of its circumference, or bicycle. So if 1 revolution is 1 circumference, pi radians, 1 revolution, is going to be 2 pi r units, 1 circumference. So let's look at angular speed in example 5. Albert Juarez's truck has wheels 36 inches in diameter. If the wheels are rotating at 630 RPMs, revolutions per minute, find the truck's speed in miles per hour. So basically this is what your car is doing. You are going to do the math that your car does. Your car doesn't know actually how fast you are traveling. Your GPS does, but your car does not. Your car knows how many times the axis is rotating, and it knows how big your tire is supposed to be. So therefore, when your tires are flat, you're actually not traveling as fast as your car thinks you are. Or when your tires are too big, your car thinks it's traveling slower than it actually is. It's very important to have the right size tire on your car so that your speedometer is accurate. Also, as your tire wears down, it technically loses some circumference because its diameter gets smaller, and again, your car will be thinking it's traveling faster than it is. So we're going to do the conversions that your car actually does. So I've got a wheel that's 36 inches in diameter. The wheels are rotating at 630 revolutions per minute. So I'm starting out with 630 revolutions per minute, so in 1 minute, and I want to convert that to miles per hour. So here we go. 630 revolutions in 1 minute. Well, converting minutes to hours is the easy part. So I'm going to say 60 minutes. I'm going to put minutes in the numerator there, is 1 hour. So now minutes have been converted to hours. So now my conversion is technically, or my rate of speed here is in revolutions per hour. I'm not looking at revolutions per hour. I need miles per hour. So like I said, the main conversion we need to remember is that 1 revolution is a circumference. So I'm going to put 1 revolution on the bottom here, and then I'm going to put the circumference on top. The circumference is 2 pi, and then the radius here is 18. You're more than welcome to do pi times diameter. I just like to keep it consistent and use 2 pi r because there are 2 pi radians in a circle. So we have the circumference, which is 2 pi r inches. So now I am not in revolutions per hour anymore. I am in inches per hour. But we don't need inches per hour. We need miles per hour. So there are 12 inches in 1 foot and 5280 feet in 1 mile. So now I would be in miles per hour. I need to multiply all the numerator together and then multiply all the denominator together. Make sure you remember pi, because that seems to be a very common mistake among students, is when you're remembering to type all this stuff in your calculator, you forget to put pi in the numerator. I get that Albert's car is traveling at 67.47 miles per hour. Kathy Nguyen races on a bicycle with 13-inch radius wheels. When she is traveling at a speed of 44 feet per second, how many revolutions per minute are her wheels making? So I'm starting out at feet per second, and I want to convert to revolutions per minute. So I want to know how fast this wheel is spinning around its axle. All right, so 44 feet in 1 second is the bicycle's linear speed. So let's change seconds to minutes first. There are 60 seconds in 1 minute. So now the units seconds cancel out, and I'm in feet per minute, but I don't want to know feet per minute. I want to know revolutions per minute. So here's where I need to convert feet to revolutions, and it's going to be a little awkward, but hang on here. Remember, 1 revolution is going to be, see now her bicycle has a 13-inch radius wheel. So I'm actually going to change feet into inches first so that my conversion using 1 revolution works better. Let's see, feet is going to go into inches. So there are 12 inches in 1 foot. So now that I'm in inches, I can say that 1 revolution is 1 circumference. So 2 pi, let's see, 13-inch radius wheel. So 2 pi times 13 inches. So now inches will cancel out. See, if I didn't change feet to inches first, that wouldn't have happened. I could have done it later, but it would have been confusing. So now I am in revolutions per minute. Multiply everything in the numerator and then multiply everything in the denominator and divide. Make sure, again, don't forget pi. And I get about 387.85 revolutions per minute.